Hello students, today I am here with topic function class 11th. Student, function is a very important topic in your syllabus and also from future point of reference. Function, let's define function. A relation from f from a non-empty set A to a non-empty set B is said to be a function if each element of A is associated with unique element in B. Each element of A. This line is important because entire definition of the function depends on this line only. If each element of A is associated with unique element in B, means each element of A has a unique image in B. Let us consider two sets A and B like this. F is a relation from A to B. There are elements 1, 2 and elements in B are A, B, C. If image of 1 is A, also image of 1 is B and image of 2 is C, then it is not a function because corresponding to 1 there exist two images, namely A and B. Because definition of function is destroyed here, because in definition we are saying that if each element of A is associated with the unique element in B, means if there is one and only one image of element, then that will be the unique element. And here in our case 1 has two images, means image of 1 is not unique. Okay, so this is not a function. Here f is not a function, whereas it is a relation, but it is not a function. F is not a function. I hope you understood it. Okay, now symbolically we write f such that A to B. Now to simplify this definition, by and large we can understand a relation as a function if no element of domain has two or more images in codomain. Same thing is said here, but language different, both convey same meaning. This is a definition of function which we can understand in simple words. I hope now you are very well aware of this definition. Simply, if there exist more than one images of a function of a point in a domain, for a point in domain, if there exist more than two images in codomain, then that function cannot be, that relation cannot be a function. Okay, so let us take another example. Suppose this is set A, this is set A, with elements A and B. This is set A, this is set B. There is a relation F from A to B. Image of 1 is A, image of 2 is A, image of 3 is B. Now what about this? This is a function. Why? Because each element has exactly one image. Image of 1 is A, image of 2 is A, image of 2 is A, image of 3 is B. Image of element is unique here because no element has two images. I repeat it, no element has two images. Two elements can have one image, but an element cannot have two images. You may little bit confuse here because image of 1 is A and image of 2 is also A, but don't be confused here. Remember its definition. Remember definition of function. For no element there exist two or more images in codomain, and this is followed here. No element in A has two images in B. Okay, two elements can have same image, but no element can have two images. This is the basic difference. Okay, I hope you understood it. Now, domain. What is domain? Domain is also termed as set of pre-images. Pre-images means elements associated with the images are termed as pre-images, and range is set of images. What is range? Range is set of images and domain is set of pre-images. Okay, as you know, range is subset of codomain. So that's all for the definition of function. Now there are certain important terms in this chapter, in this topic. Next is equal functions. How can we say that a function, two functions are equal? So here it is, two functions f and g are said to be equal if and only if. IFF stands for if and only if. Okay, now under what conditions? Domain of f is equal to domain of g, codomain of f is equal to codomain of g, and values of functions are equal for all elements belonging to their common domain. If this is happening, then we can say that these two functions are equal. Okay, I hope you got it. Means for a function to be equal, we must have their domain should be same, their codomain should be same, and their range should be same. If this is happening there, then that functions will be equal. Now if two functions f and g are equal, then we write f is equal to g. If two functions are equal, then we write f is equal to g. Now what is a real valued function? A function f such that a to b is said to be a real valued function if its codomain is subset of real numbers. A real valued function is that in which codomain is the subset of real numbers. If this is happening there, then that will be a real valued function. In our syllabus, only real valued functions will be discussed here, because we do not have any case of functions which are not real. Now, how to find the range of a real function? Okay, now to find range of a real function, simply we first put fx is equal to y. After that, solve x in terms of y. Now, for those values of y, now remember this, for those values of y, x belongs to, for all those values, x belongs to domain, then that collection of y will be set of images, and that will form the range. Okay, I hope it is clear. Now, some standard real functions. We define here some important real functions which are important for the point of view of your study and also for knowledge. We also study their graphs, range, domain, etc. Now, first is constant function. What is a constant function? In a constant function, input may be any real number, but output is always fixed, and it is a constant. As in our case, fx is equal to k. Here x belongs to real numbers. For every real numbers, there associated a unique element, that is k, and we cannot get anything apart from k. Here domain is R, and what will be the range? Range will be the only element, that is k. So, what will be the graph of this function? As it is given here, fx is equal to k, and k is a constant. So, just simply a line parallel to x-axis. Now, move to another function, that is identity function. In identity function, what is input? That is output. Means if you put here 1, you will get 1. If you put here 2, you will get 2. If you put here 3, you will get 3. So, there is no difference between range and codomain elements. So, domain of this function will be R here, and same will be range R. Now, what will be the graph of this function? Simply just this will be a straight line making an angle 45 degree with positive direction of x-axis, and this will be from passing from origin and extended from first quadrant to third quadrant. I hope its graph is clear to all. Now we shall study some other graphs, some other important graphs. One of them is modulus function. Modulus function. Modulus function is fx is equal to mod x, it is equal to minus x and x. When will be minus x? When x is less than 0, and it will be x when x is greater than or equal to 0. Now its domain will be R and range will be 0 to infinity, including 0 here. It also includes 0. Now range cannot be negative, because if you put f of minus 1, then we shall get minus 1 is equal to 1. So you will always get positive numbers, and the least number here will be in range 0. Now look at graph of this function. Now to plot graph, we take two functions here. First is y is equal to minus x, and second is y is equal to x. Y is equal to somewhat similar as identity function. This is making angle 45 degree, and only difference with y is equal to minus x is that here x is negative, so it will start toward second quadrant, making an angle 45 degree. Both will be like incident and reflected ray. So this is the graph of the modulus function, and suppose you are told to make graph of modulus x minus 1. Nothing to worry, simply take point 1 comma 0 here. This is 1 comma 0. Now make graph like this. Okay, some other functions may be fx is equal to mod of x plus 2. How can you plot graph? Just take minus 2 comma 0. Okay, because x plus 2 is equal to 0, it will imply x is equal to minus 2. Now minus 2 comma 0 will be the point where this line strikes with x axis. Now plot like this. This is the graph of the mod x plus 2. So what have you seen is that its striking point is shifting according to the function. If it will be x plus 3, then it will be minus 3 comma 0, and so on. Now I hope its graph is clear to all you. The domain, I told you about domain. Now there are some important relations, some important formulae. You must remember them. If x square is less than or equal to a square, implies and is implied by. Now what is implies and is implied by? Implies and is implied by is similar like I double f, if and only if. If it means a is implies and is implied by b, it means if a is true, implies b is also true. Okay, and vice versa, if b is true, then a is true. I hope you understood it. I repeat it. A implies and is implied by means if a is true, then b is true, and vice versa, if b is true, then a is true. I hope now it is clear to all. Next is further we can also write it mod of x is less than or equal to a. Okay, and is implies and imply means x is greater than equal to minus a and less than equal to a. Now second is x square is greater than or equal to a square. It is implies and is implied by mod of x is greater than or equal to a, and this is implies and implied by x is less than or equal to minus a or x is greater than or equal to a. One of them will follow here. There are two cases. There is a symbol or, that means either this will be true or this will be true. Okay. Now similarly we can write properties of simply containing less than symbol. X square is less than a square. This will imply, that is implies and implied by mod of x is less than a, and this will implies and is implied by minus a is less than x and x is less than a. So it is quite similar with less than equal to or greater than equal to. We similarly can replace less than or equal to sign with simply less than only. Okay, I think it is clear to all. Now another property is if x square is greater than equal to a square and x square less than or equal to b square, then we can write x is greater than or equal to a and less than equal to b. This will imply here mod will be there. This will imply x belongs to minus b comma minus a union a comma b. Okay, now another property is mod of x plus y is equal to mod x plus mod y, and this is implies and is implied by x comma y is greater than or equal to 0 or x comma y is less than or equal to 0. Okay, so these are few properties. You must note these all. I hope it is clear to all of you. Now move to another function, that is greatest integer function. In greatest integer function, uh, in greatest integer function f such that r to r, and greatest integer function means actually it will be equal to its extreme left neighboring point. Okay, extreme left if there is any fractional part. Actually there are two parts in a number. In a suppose there is a number x, then it has two parts. One is called fractional part and other is called integer part. Okay, now this integer part is called greatest integer function. Simply we can also call it greatest integer. It means if there is 2.75 is, it means it will be 2 because its extreme left integer is 2, and if there is 3.9, it will be simply 3 because extreme left integer will be 3, and if it is a negative minus 2.9, it will be minus 3 because extreme left integers to 2.9 is minus 3. So this is all for greatest integer function. Now its domain will be real numbers, and its range will be set of integers. Means we always get output as integers, whereas its input is real number. Okay, I hope it is clear. Now in number line you can understand that there are various points on number line 1 2 3 and -1 -2 -3. If there is number 1 point something, then that its next extreme left neighboring point integer will be 1, and if there is something like 2.1 2.2, then its extreme left integer will be 2. And in case of negative integers, if there is a -1.5, this will be here, and its extreme left integer will be -2. Okay, now plot graph. In graph you can see that x-axis, y-axis, and at graph is splitting at integers point because there is a jump at integral points. For example, if 2.1 2.2 2.3 and so on, then all these will be equal to 2, means at these all points there will be a continuous graph, and as soon as you will get 3, the graph will jump suddenly and it will reach to value 3. So there is a jump, you will see a jump at all integral points. So this is the graph of greatest integer function. Now signum function. What is a signum function? Signum function is equal to mod x upon x when x is not equal to 0, and 0 when x is equal to 0. There will be only 3 points in its range, that are -1 0 and 1. The domain of this signum function will be R, means real numbers, and range will consist of only 3 elements, as I told earlier, -1 0 1. So its codomain is real numbers, its domain is a real number, but its range has -1 0 1. Now when you put x is equal to 1, you will get there is you can see that at this point there is a line, continuous line at this point when x is 1 more than 0. Okay, and when x is 0, you will get y as 0. So this is the point. The highest value of fx is 1, and the lowest value of fx is -1. So this is the graph. Now consider some other functions. That is exponential function. As you know, exponential function means any function like this, a to power x. You can also particularly write 2 to power x, 3 to power x. These all are exponential functions, and in exponential function, domain is always a real number and codomain is a real number, and we shall study about its range. But there are certain assumptions before define this function. Here always a is greater than 0 and a is not equal to 1, because if a is equal to 1, then value of exponent of 1, any number, will be 1 itself. So we exclude this case. We take only those where a is greater than 0 and a is not equal to 1, is called exponential function, and where domain is R and range is 0 to infinity, excluding 0. Here range will be 0 comma infinity, means 0 will not be included in range, means we can never get a to power x is equal to 0 for any real number x. For any real number x means for no real x this will be 0. So we can never get 0 as a part of its range. Now graph, how to plot graph? Simply you can see that if x is equal to 0, then value of the function will be 1. So 0 comma 1 will be the intersection point, and after that its curve slightly increases, and it increases, it continuously increases. And whereas in its other part, it is like an asymptote, means it looks like it will touch x-axis, but actually it never touches, because you can never get fx is equal to 0, so it will never touch x-axis. Okay. Now another graph of y is equal to a to power x, when here a is, in first graph a is greater than 1, and in second case a is less than 1. Okay, so this is for like these function 1 by 2 raised to the power x, all these, since 1 by 2 is less than 1, so this will be the graph. And you can also consider 1 by 3 raised to the power x. So first graph is for a is greater than 1, and second graph is for a is less than 1. Now logarithmic function. Logarithmic function is quite similar with the quite reverse, you can say here reverse, means opposite to exponential function. Here fx is equal to log x base a when x is greater than 0 and a is greater than 0 and a is not equal to 1, is called logarithmic function. And in logarithmic function, domain is 0 to infinity, open interval, and range is capital R, means set of real numbers. Here range is equal to capital R. Okay. Now you can see here graph of logarithmic function. It will intersect x-axis at 1 comma 0, and in exponential function it intersects at 0 comma 1, whereas in this case it intersects at 1 comma 0. Now graph 2, where a is less than 1, this intersects at 1 comma 0 on x-axis, which is quite similar with this graph. So these are important graphs. Now move to another page, and algebra of real functions. Algebra, here we shall discuss about some additions, difference, product, quotient of functions. How can we add to functions, under what condition we can add a function. So let's discuss them. Consider f such that d1 to r and g is d2 to r be two real functions. If we didn't have say here that these are real function, it is actually not required, because we all are studying only real functions. So need not to say here that these are real functions. But if you are written here, then no problem at all. Now define a function f plus g such that d1 intersection d2, means domain of f plus g will be common domain of d1 and d2. Then we can simply write f plus g x is equal to fx plus gx for all x belonging to d1 intersection d2. Now difference, how to find difference? Same condition will be here for difference. No, there is no change. It will be like addition, same definition. So you do it at your own level. Now product. In product, which is also quite similar with about to addition and difference of sets of functions. So fg such that d1 intersection d2 to r, and it can be defined fg into x is equal to fx into gx for all x belonging to their common domain. Now questioned, let f such that d1 to r and g such that d2 to r be two real functions, then f upon g such that d1 intersection d2 minus, here it is important, minus means we delete, we remove those points, those at which gx is 0. Okay, wherever denominator is 0, we delete those points, we will not include them. Means we should have gx is equal to, gx is not equal to 0 for all points present in domain, so we excluded these points, and after excluding from common domain, then we get the domain of f upon g. Okay, f upon g of x is equal to fx upon gx for all x belonging to d1 intersection d2 minus x such that gx is equal to 0. Now what happens when multiplication of a function by a scalar? Is suppose a scalar is multiplied with a function like this k f of x, then simply it will multiply the entire function k of f of x. So I think you understood it. Now reciprocal of a function. Reciprocal of a function is let f such that d to r be real valued function 1 upon f of x is equal to 1 upon of x for all x belonging to d minus x such that fx is equal to 0. Now students, we shall discuss some important questions of your exercise 2.3, as we have already discussed 2.1 and 2.2 in our previous video. So if you want to solution of questions in 2.1 and 2.2, then kindly visit to the videos and watch them fully. Now exercise 2.3 NCERT book. Find domain and range if fx is equal to minus mod x, and second is fx is equal to under root 9 minus x square. In first, it is very simple to understand. Its domain will be R, means set of real numbers, and range will be minus infinity to 0, because you are not going to get any positive value from this, because if you take any real numbers, it will always give a positive value, so, and if there is a negative, that means you are going to get always a negative value, so its domain will be a negative real number, you can say that, including 0. Okay, so in first question, in first part, domain is real numbers, and range is minus open interval minus infinity to 0. Now in question number 2, fx is equal to under root 9 minus x square. Here as you know that any under root will be valid if x is a real number. For x to be a real number, we must have x is greater than or equal to 0. So here 9 minus x square must be greater than or equal to 0. Now after transposing, we can get x square is less than or equal to 3 square. Now visit to properties. As I told, in case of modulus function, there is a property: if x square is less than or equal to a square, then we can write x is greater than or equal to minus a and less than or equal to a. So here we shall use these properties. After applying this, you get x is greater than or equal to minus 3 and less than or equal to 3. So here domain is equal to closed interval minus 3 comma 3. I hope domain of this function is very clear to you. Now find range of this function. Now to find range of this function, first put y is equal to under root 9 minus x square. After squaring both sides, you shall get you will get y square is equal to 9 minus x square. That implies x square, because solving x in terms of y, x square is equal to 9 minus y square, and that will imply x is equal to plus minus 9 minus y square. Okay, we took here x is equal to plus minus because here in domain x is negative also, so we take both we consider both values positive as well as negative, so we took here negative plus minus. Now students, you can observe here that y cannot be negative, because in function y is not negative here, means fx is not negative here, so we can consider here only positive values. Now maximum value of y can be 3 here, because if y exceeds 3, then this will not be possible at all. If this exceeds here, then it will not be possible. So y cannot be greater than 0. This is not possible. Maximum y can be 3, and least y can be 0, because we cannot take negative, so it cannot be less than 0. So range will be 0, and range means y can take any value from 0 to 3. I hope it is clear to all you now. Now take question number 3. Fx is equal to x minus 5. Now we have to find f of minus 3. In solution, just put x minus 3 in place of x, and after solving you will get minus 11. Now try question number 5. Find range of fx is equal to minus 3x. X belongs to R. X is greater than 0, means x will be positive always. And to question number 2, fx is equal to x square plus 2 for all x belongs to a real number. And in question number 3, in part 3, fx is equal to x belongs to R. Actually it is an identity function, so it is not difficult to find the range of this function, as we have already studied it. Now solve question number first. Fx is equal to 2 minus 3x. Now put y is equal to 2 minus 3x. After solving x in terms of y, we shall get x is equal to 2 minus y upon 3. Now you can see here it is clear given that x is greater than 0, so we can write here 2 minus y upon 3 is greater than 0, so 2 minus y is greater than 0. Now this will imply y is less than 2, so its range will be open interval minus 2 in minus infinity to 2. Now take part 2. Fx is equal to x square plus 2. Now put y is equal to fx, so y is equal to x square plus 2. This implies x square is equal to y minus 2. This will imply x is equal to plus minus y minus 2. Now here range will be, here 2 is included, okay, because y minus 2 for this function, for this to exist, y minus 2 must be greater than or equal to 0, means y is greater than or equal to 2. So y will be greater than or equal to 2. So y will be greater than 2 but less than infinity. So this will be domain of this function. And in part third, as I told you, this is an identity function, and its range will be R. I hope ये आपको clear है. Now move to other questions of your miscellaneous exercise chapter 2. In first question we have to check whether we have to show that f is a function whereas g is not a function. Okay, so since function is changing its definition, function is changing its behavior at x is equal to 3, so we check at x is equal to 3 from both f3 is equal to 3 square is equal to 9, and also f3 can be found 3 into 3 is equal to 9. Both are equal here from both x square and 3x, both values are equal, so this is a function, f is a function. Whereas in its definition is changing at 2, so we shall find g2 in two cases. g2 is equal to e square, that is 4, and in second case g2 is equal to 3 into 2, because 3 it is 3x here, so put x is equal to 2 simply. 3 into 2 is 6. It means 2 has two images. Okay, namely 4 and 6. So by the definition of function, it cannot be a function because no element in domain can have 2 or more images in codomain, so it is not a function. Now move to question number 2. Fx is equal to x square. Find 1.2 f of 1.1 minus f1 divided by 1.1 minus 1. Now simply substituting values of x, 1.1 whole square minus 1 square divided by 1.1 minus 1 is equal to 1.1 minus 1 into 1.1 plus 1 divided by 1.1 minus 1. Now after solving it, you will get 2.1. Now question number 3. Find the domain of the function fx is equal to x square plus 2x plus 1 divided by x square minus 8x plus 12. As you know that this domain are those points at which function defined. Now this function will be defined everywhere only at that point where denominator becomes 0. So here this cannot be 0, so solve it. After solving it, we shall get x is equal to 2 comma 6. So these are 2 points where denominator can become 0, so exclude these 2 points from real numbers so that you will get desired domain. I hope it is clear to all. Now solve question number 6. Here fx is equal to x square by 1 plus x square. Just simply put fx is equal to y. Now solving y, x in terms of y. After solving it, x square is equal to y upon 1 minus y. So x is equal to plus minus under root y upon 1 minus y. Now to solve it, we just took y into 1 minus y, and for that we have to multiply denominator as well. As you know here, y can never be equal to 1. Now who will decide? Numerator will decide the fate of this square root. So for this we just draw a number line, infinity to minus infinity, and here points will be 0 and 1. So draw these points 0 and 1. Now write this y into 1 minus y in linear factors
like x minus a into x minus b. After writing, it can be written y into y minus 1. Now these values of y here will be 0 and 1. Now since its sign is negative here, so start with negative sign, minus, plus, minus. Now where this will be positive? This will be positive in 0 to 1. So your range will be 0 to 1, but it will be semi closed, semi open interval, because 1 is not included here. Now move to question number 8. Here f is equal to 1 comma 1 2 comma 3 0 comma minus 1 minus 1 comma minus 3. We have function from z to z defined by fx is equal to x plus b for some integers a comma b. Determine a and b. Here fx is equal to x plus b, just simply, as you know that here 1 comma 1 means f1 will be 1. First one is domain and second one is range. So f1 is 1 and in second f2 is 3. So just put x is equal to 1 in first case and x is equal to in second case. You will get two relations, and after solving that you will get desired a and b. So after putting x is equal to 1, you will get f plus b. A plus b is equal to 1, and when you put x is equal to, you will get x 2a plus b is equal to 3. Now solving these two, you will get a is equal to 2, b is equal to minus 1. Now question number 9 here. R is equal to a comma b such that a comma b belongs to natural number and a is equal to b square. Are the following true? A comma a belongs to R for all a belonging to n. A comma a belongs to R. This will not true, because if you take 2 comma 2, this will imply, as per condition, 2 is equal to a square, which can never be true, because 2 cannot be equal to 4. So this is not true. This is not true. Okay, it is given here false. So a comma a does not belong to R. Now take another example for second. Take 9 comma 3 belongs to R. This will imply 9 is equal to 3 square. That imply 9 is equal to 9. It means this is true. In second case, if you take 3 comma 9 belongs to R, it will imply 3 is equal to 9 square, which is false. Means a comma b belongs to R does not imply b comma a belong to R. So this relation is also not true. Now in case third, just consider examples. 16 comma 4 belongs to R, 4 comma 2 belongs to R. This will imply 16 is equal to 4 square and 4 is equal to square. This is true. But if you take 16 comma 2 belong to R, it will imply 16 is equal to square, which is false. Means a comma b belongs to R, b comma c belongs to R will never imply a comma c belong to R. I hope you understood it. Now question number 11. Let f be the subset of z cross z defined by f is equal to a b comma a plus b such that a comma b belonging to z is a function from z to z. Now we have to check whether it is a function or not. For a relation to be a function, it must satisfy its definition. That means no two element can have two or more images in codomain. So here function is f of ab is equal to a plus b. Now take 6. f6 can be written f of 6 into 1 is equal to 6 plus 1, that is 7, and 6 can also be written 2 into 3. In this way it can be written 2 plus 3, which will be equal to 5. So in one case f6 is equal to 7, and in another case f6 is equal to 5. It means 6 has two images, namely 7 and 5. Then it means it is not in purview of definition of this function.
So I think this cannot be a function. Okay, I hope you enjoyed this video, and you have cleared many concepts and understood these all definitions and examples. So I, at the last, I want to say thank you to all for watching this video. Thank you very much.